Alright, so in this video we're going to be looking at parts per million in acid-base titrations. So let's get right into it. And before we get in, be sure to drop a like on the video and subscribe if you want to learn about physics, chemistry and maths. Alright, so what we're going to do first is we'll have the concentration. We'll do a nice problem first, okay? So we're going to do it at the top right. So the concentration of dissolved oxygen in a water sample is 0.002 moles. Okay, so cons oxygen 0.0002 moles. Calculate the concentration of dissolved oxygen in the water sample in ppm. So ppm, we want it in ppm, okay? So molar mass of oxygen is equal to 16 multiplied by 2, because the atomic mass of one oxygen is 16. So then that we have two of them, so you get 32 g mole, okay? So there are 0.0002 moles of dissolved oxygen in 1 liter of the water sample. So that would mean that we'd have 32 multiplied by 0.0002, which is equal to 0.0064 grams, okay? Then we multiply that by milligrams, so then we'd go 0.0064 multiplied by 1000 mg is equal to 6.4 milligrams. And then concentration of dissolved oxygen in water sample is 6.4 ppm, okay? Cons O2 is equal to 6.4 ppm. So milligrams and ppm are the same measure, okay? So let's just run through that again. So I'm going to clear this. I'm going to clear everything out of the way and just run through that again. Okay, I'll just highlight it here. So we had the concentration of O2 is 0.0002 moles, and we wanted to get it in parts per million. So we got the molar mass of O2, which is 32 grams per mole. So we multiplied 32 grams by the 0.0002 moles, and we got 0.0064 grams. So then we multiplied that by 1000 milligrams, so we got 6.4 milligrams, and then the concentration of O2 is equal to 6.4 parts per million, because milligrams and parts per million are the same thing. Okay, so we're going to clear. We're going to do another one. Alright, so concentration expressed in terms of percentages. Okay, so we'll write that down. Concentration expressed in terms of percentages. Okay. Okay, so we can have like WV or volume in percentage. And we have different concentration units. So that'll be percentage weight per volume, percentage volume per volume, and we can have percentage weight per weight. These are all percentages, okay? So we have a solution contains 20 grams potassium hydroxide, okay? 20 grams potassium hydroxide, okay? Potassium hydroxide, potassium hydroxide, which is actually KOH, so you can rub that out it wouldn't go KHO, it would be KOH. So potassium hydroxide in 1 liter of solution. Express the concentration of the solution in weight per volume. Okay, so 1 liter, okay. So the solution contains 20 grams KOH in 1 liter, so 100 cm3 would equal to 20 multiplied by 100 over 1000, which would be equal to 2 grams KOH. Okay, so then cons KOH solution would equal to 2% weight per volume. Alright, so we had 20 grams of potassium hydroxide in 1 liter. So we wanted to get it 100 cm3, so we did 20 multiplied by 100 over 1000, we got 2 grams KOH, and therefore there was 2% weight per volume. Alright, nice. So now we'll do another one of 25 centimeters cubed. We'll change the color this time. Change to green. Much lighter green. 25 cm3 ethanoic acid in 500 cm3 solution. Okay, in 500 cm3 solution. Express the concentration of ethanoic acid in the solution in volume per volume. Okay, so cons in V over V. Cons in V over V, right? Ethanoic acid. Ethanoic acid is CH3COOH. Okay? So we have 25 cm3 of that. Concentration of ethanoic acid in solution. So in 500 cm3. So 100 cm3 of solution contains 25 multiplied by 100 over 500. So 100 cm3 equal to 25 multiplied by 100 over 1000. And this is equal to 5 cm3 of CH3COOH. So therefore we'd have concentration in solute would be 5 equal to 5 V/V. Okay, very good. So thanks for watching. Be sure to like and subscribe, and I will see you in the next one.